Okay, we're going to start the session from 2 p.m. The session is by Daniel and Kitayama-san, and the title is From Static Rules to Reasoning Platforms, Scaling Intelligent Canary Delivery in 2026. Okay.
All right, thank you so much. Hi, everybody. Thanks for joining. Are you enjoying this conference? Yes, looks like some sleepy after quick lunch. Yeah. So Shingo and I, we're gonna talk a little bit about like AI ops today. So I got a quick question. How many people are actually using Argo right now? ArgoCD? No? Okay, how many of them are actually like a platform engineer or a DevOps engineer today? You? Only one? Okay. And then developers. What others? What others, guys? Comedian or? All right. That sounds good. Okay. So because we're gonna keep talking about like AI ops today, or like a more like a infrastructure and Argo, something like that. So my name is Daniel. I'm from like a Boston and from IBM, and I'm Deborah and among others. You can actually Google me, Daniel O, and then you can find me. Hey, here's my colleague Shingo.
Yes, I'm Shingo from the Principal Solution Architect at Red Hat. So today we will also explain about our static route to the reasoning platform. So of course, so deep dive into the Canary delivery. So but I will also cover the chapter 1 and 2. So and we will have the 5 chapters in total. So the first, we're gonna focus on the complexity. So, let's dive into the complexity. So as you know, we are involved into the very big complexity. So in the world. So of course, so operator is also focusing on the Kubernetes. So you also might know that the Kubernetes and the container or cloud native services or like that. So, but you know that the Kubernetes is one of the big problem. So that's it's a kind of the making the complexity itself. So, but the some of the microservice is also expanding day by day. So according to the certain surveys, so the annual growth rate is also the microservices has been the increase 3% in Japan. So of course, since 2022, so microservices counterpart organization have tripled since 2022. So it's more like the no longer the specific technical debt, but it's cognitive load. So that this is one of the our reason for development failures. So that, as I said, so the Kubernetes or GitOps is also the including in this complexity. That means Japanese also governance is also focusing on the specific the traditional rule or analysis, but it's a little bit unsuitable for GitOps or cloud native automated operation. But to manage these issues, so I think some of this are control this problem by observing the specific the pipeline success rate. So like 90% success rate is also more successfully to deploy the some application. But honestly, you know, so it's more weak or it's more fragile. So why does it so fragile? So because looking at the success rate, so can actually hide the serious problem. So depending on the small area, so that we can run into the two kind of the traps, like the false positive and false negative. So that's false negative. I think that some of the engineer want to deploy their application in the deployment environment. but we often restart them when it's failure. But anyone want to investigate the root cause on this failure, but no one want to waste the time looking into the deep dive. But whereas a negative false negative, so this is a scary one. So where all your metrics looks perfect, but behind the scenes, so your data is just broken or corrupted. So it look like a metrics right. So that's we have sometimes it's kind of the difficult way or difficult issue on this moment. So we are also think about all the days. So system status was simply binary, so up or down. So but recently, so current situation is a partial. So and sometimes so we are of course so finding the specific issue or root cause on this map area. So that, for example, this is one of my customers' story. So of course, so they deployed their application on their deployment platform, but the system status is also the past. But of course, they are trying to find the specific upgrade or specific issues. So in the literal storm, so of course they deploy the one application. So the pipeline is also automated in the this area. But at the staging area, so the most shows the green status is occurred. But at the production area, so we can find the specific issues. So unexpectedly. So that DB crashed or any application is stopped. So it's a more very fragile application, but it's more real world. So that we need to think about how to destroy these specific issues. That's why so we shared a reasoning layer today. So reasoning layer is one of our platforms. So and this is a big challenge for us. So now we are trying to focusing on the static automation, but we try to move to the reasoning platform at this moment. So this means simply using the AI agent for the deployment measurement. So, but of course, so it's more like the digital SRE. So it means a very big challenge that we try to understand the reason with this problem, but the AI also understands the same view, so that we also tackle these kind of the gray failure. And of course, they can also understand the specific appears completely green. So that's next one is that the transition or transition to the agentic delivery. So we show the static rules, so that its error is occurred over the 1% higher. So, but we also decided the rollback. So, but now, so we try to find these specific decision with the reasoning platform. It means so error increased, but they match a known upstream outage. So at the moment, continue the rollout. But we try to find the monitor latency as a key metrics, so that the load of the agent is more like the autonomous logic gate. So between the CI/CD pipelines, it's a more important things for us to decide the very successful rate. So architecture is simple that we have the three plane. So the first one, the data plane, is also have the trace and the metrics and the logs. So within the specific open source component, but this layer, this data is also flowed into the reasoning plane. So the reasoning plane also shared the LLM model with the agentic provider. So with the domain specific log. So it's a very important thing to understand with context. So of course, this decision is also provided to the control plane to analyze or to handle our application deployment with the ArgoCD and Argo rollout automatically. In the log, we also share the context and history. So the log is a very popular things within the AI services, but the context is more the convenient things to understand our status is how do we our status is better or not. So that we try to find a specific context, like if we want to deploy this application within the working time. So it's a more important things not to go out our working time. So the history is also the same. So we had many experience within our workload. So that once the database crashed or any application is stopped, so we understand why this application is so fragile also. So that these two components, the context and the history, is a very important things to find the specific successful deployment. So log is also the synthesize to the any evidence. Of course, not only log, but also the multimodal analysis is a very important thing. So the agent uses the multimodal analysis to understand each situation. So that adjusting the situation, the agent uses accurate model for analysis. They continuously understand which metrics is the better or which what happened in this system, or any, of course, the bottleneck is important to find the specific area to make up the green. So that if we have a log status with connection timeout or trace shows service A or B is slow, so that we also define the network configuration is a little bit scared, something like that. So it's an important thing to understand how to define the specific application deployment successfully. So that digital SRE personality is same things to understand the definition. So that finally, so this activity means that we can define the digital SRE personality. So if you deployment manifest, so you can configure the deployment persona as aggressive for deployment or conservative on the production environment. So that active investigation is also the same. So we can find it during the Canary deployment, so including the triggering additional profiling. Finally, so human in the loop is a decision for our human view or perspective. So that, of course, so once AI decided the specific success or false, so we need to judge the activity with the approval or rejection. So this is a collaboration with the AI for us. This called is that so human in the loop. So that it's important metrics or methodology for our session. This is my introduction. That's it's a part of the how to implement this kind of the methodology for us. It's it's a time to hand over to the Daniel.
Sure. Great. Thanks. Great. So Shingo really bit talk about the what kind of challenge do you have? Why you think about this AI ops thing? Because you probably heard about like a CI/CD or advanced pipeline or like a progressive delivery as well. And now everybody doing is AI, like a Gemini, ChatGPT, or among others. And then people a little bit scared. Okay, is it gonna eliminate my jobs? And that's not true. So you're gonna change your mindset and then your skill and capability. Just imagine that like 10 years ago, nobody actually using like a smartphone at a time. And then, but never ever, so how do people actually work? They actually do the like a phone call or check your email. And then after like 6 p.m., they never ever check the email. But now things change that. And then it increases your productivity, but also accessibility as well. And then people learn from new devices how to work better. Exactly same thing. So rather than letting new agentic stuff eliminate your job, you can make it better your value with the AI. So as Shingo said, with the AI ops and agentic AI, you can say like a digital SRE, and then what that looks like, and what architecture looks like, something like that. I'm gonna give it a try to show what open source softwares actually make this happen. So basically, Argo is one of like a city foundation project, and then it actually includes a multi-sub project like ArgoCD, specialized continuous delivery, and then Argo Rollout, specifically progressively delivery, and like a Canary and A/B testing, and then there are workflow pipeline and so on. And then, as you mentioned earlier, so we're gonna put in together with the agentic AI stuff in the middle of this progress delivery using ArgoCD. So ArgoCD allow you create like an analysis template, add like a bunch of YAML file, and then that YAML file allow you to point to your agentic AI. So agentic AI could be implemented in the Python, Java, even COBOL. I don't blame on COBOL people. So any program language, you can do that. And then based on that agentic AI, like a Shingo mentioned, digital SRE. So that is the like analyze your like infrastructure logs and metric autonomously, and then give us some observation. Okay, this deployment gonna be bad because based on logs, we can find some potential like a memory issue or performance issue for scalability on Kubernetes or some other stuff. And then it probably autonomously just stop and back to the delivery. I mean, back to the original version, or notify human being like you guys, and oh, so we got some potential issue, and that is your judgment call, like a human in the loop. And that is a new like architecture with the ArgoCD. And then the ArgoCD is just one application deployment, the one pipeline. But imagine that in production, in reality, so you probably maybe 10,000 application, like a microservices, the Java, .NET, Python, or COBOL, whatever you call that. And then you don't want to create the 10,000 analyst template for like a agentic AI, like a progressive delivery. So that's why you probably maybe centralized some control tower, which is like a just like a source of truth, like some kind of GitHub repo kind of thing. And then you can put in together like a define rules and agentic configuration, and every other like a pipeline actually synchronize that rules and policy, and then try to make it better AI ops progress delivery. And then that we can say like a reasoning as a code, just like you probably heard about infrastructure as a code, like using Ansible, Terraform, and among other like Puppet tools. So you're gonna put together all configuration relevant to your infrastructure into source repo, which is like a most likely GitHub repo, and then every infrastructure pull down that thing and synchronize every single minute, and then just roll out every infrastructure. So you're gonna maintain, control your infrastructure stuff. Now you're gonna control reasoning, AI model, agentic stuff with that thing. So, and then in the end, you can quickly scale your agentic AI ops with like a many like a deployment application and so on. So now we probably think about how to control this kind of thing. So AI is everybody saying non-deterministic. Every time you ask the same question, same order, same instruction, and then your AI model actually sends it back to you something different answer. So that is a non-deterministic. So, but you are a human being as SRE or platform engineer or DevOps engineer, you are not non-deterministic. You are deterministic people. So how do you working together? Because you still working your colleague, team, and readers as like a known workflow and processes. And then when you're using this AI ops and reasoning platform, and then you probably combine some new rules and policy for controlling non-deterministic platform. So that's why here just some kind of like a chit-chat, how to combine non-deterministic versus deterministic stuff. So previously you could maybe define or make some measurement criteria based on like a more accurate number or matrix. So if you fulfill this kind of number, you're gonna go forward to like a success, or if not, it will be fail. But you cannot do that with a non-deterministic AI model with the agentic AI. Instead of, you can maybe have some scoring method. So if you have more than 90% success, we're gonna go for like a good signal, or if not, it's gonna be not going to production. And then every time you're gonna fast checking based on the agentic AI, like based on a bunch of the cluster logs or deployment logs and application logs metric, and it give it back to you, like a notify you, like a human in a loop. Because the final call, you don't want to let AI model or with agentic AI decide the final stuff. So this is kind of how to change your workflow based on non-deterministic AI ops platform. And then once you stand up this AI reasoning platform, and you can finally, eventually you can have intelligence as a service. And this is not only benefit for platform engineer, but also developer. So you heard about a lot of some new paradigm. So everything you need to do, something previously in production from ops people, you're gonna make that shift to left, which means developer. For example, security. So a lot of people, security people, like InfoSec or like a DevSecOps people, actually they do more than 10,000 like a checkup list of how to secure this application workload, resources, or among others, in terms of the governance, data operation. And then if that security checking happen at the very start when developer designed the application, it probably eliminated the technical debt and many kind of money in the production. So that is a rapid shift. But it burdened a lot of things in the developer's shoulder. But your company not gonna give some more money to developer. You give some more jobs. And then luckily you got some AI tools today. You can actually use that and then maybe make it better experience and then make it faster. But this kind of similar concept. As long as you have AI ops and the reasoning platform, and you have get rid of some burden from developer. Developer keep doing developing code, but not just a coder. If you do just coding application, your job will be eliminated. Just like other hyperscaler company, they actually laid off of maybe 10,000 people, software engineer, like Google, Microsoft, and IBM, among others. So you should be something different developer. And then, so let's jump into the demo and how that looks like. And then, so I'm using Argo Rollout today. So here's my Argo Rollout. And I already deployed a bunch of the application here running on Kubernetes. This is my progress delivery controller. And here's my Quarkus application, which is a Java, new like a Java framework, like invented 7.5 years ago. I was one of the like a member of the Quarkus stuff at the very starting. And here is the Kubernetes agent. This is actually agentic AI. So this agentic AI basically running on Kubernetes as well. And then I actually built this Kubernetes agent on Quarkus. So back to here, and then I'll probably show a little bit more. So this is our demo scenario. And we're gonna start some of the change in my local file system and push it and come it into my Git repo. And it will trigger the Argo rollout. And Argo rollout, around you have some kind of plugin for AI metrics plugin. This AI metrics plugin allows you to invoke any remote agentic AI application, regardless of the program language. You can actually build Python, Java, JavaScript, whatever your preferred language. And then that agentic AI application access your Argo and application and all rollout logs and metrics in a real time. And then it tried to connect to your link to AI model and try to analyze their logs and find out, oh, there are something, a potential issue, what's the matter, and it just gonna stop and just roll back to previous version. So that kind of thing. And in order to make this demo system, I have like three different layers. First of all, GitOps control plane, which is based on using Git and ArgoCD and Kubernetes as well. And then a progress delivery engine, which is basically Argo rollout. And then you can have like a Kubernetes resources and then using rollout for represent some of the UI application using HTTP proxy router. And then the last thing is the actual AI analyst and the reasoning layer, which is using AI metrics plugin and then Kubernetes agent based on Quarkus and among others. So my old social media handler, Daniel 30 number, because there are many Daniel around the world. So I end up with the number 30, but you can Google me and then you can find, and you can fork this repo anytime, and then you can give it a try on your local machine. Okay. So here's I just running on logs. This is I go rollout logs, and then you can see that the revision version 1. So and then this application it can scale by default 10 applications, just like a production. 10 applications scale out, and then first version, and this is my Quarkus application for my Agentic AI. So if I go to IDE. And analyst AI template, as I mentioned earlier, so it's a pretty simple CRD. So analyst AI template, and there are a few like an argument, which is most likely some name kind of thing. And here's a key thing is a plugin. And then as I mentioned earlier, so I go rollout, or rather you have the like an AI metric plugin. And then when I set the AI metric plugin, you can actually point to agent URL. So this is my agentic AI based on Java application running on Quarkus. It actually deployed by ArgoCD as well. And this is a Kubernetes service URL, not like a FTP public URL. And then like a role is a stable Canary, and then what is the source of truth? That what is the original source code? This is the source code. So it's very simple, and it's not a big thing. So if you consider like a AI ops, wow, so how many things I have to implement and how complicated it is? Not at all. So it's pretty simple. And then the rollout part, so I actually deployed the first the version 1, and I'm going to try to use some separate version. So in the meantime, let me go to my application here. So Java application. I don't know how many people are actually some experience with the Java. No? Okay, fantastic. Oh, one. That's great. So this is like a Java, and the Quarkus actually integrate with the LangChain 4j. So LangChain, you probably heard about that, like one of a Python ecosystem. Like some kind of library, how to communicate between your Python application with AI model, like a Gemini, ChatGPT, whatever you want use. So it gives some like how to implement prompt engineering and memory management and like a RAG and among others. So Java also need that thing as Java people implement similar concept and capability, and we named on LangChain for J. J means Java, but not copy and paste from LangChain at all. So, and then go to application property, and then so application name Kubernetes agent, which is like a service name at the same time, and so I'm gonna using like an OpenAI, by the way. It's a small model, pretty much a small model. But you can actually set up like a production model, maybe Gemini, or a developer model like OpenAI based on your budget and like a plan kind of thing. And when I go to some of the application, you can see that there are many folders, but here's the thing is agent and A2A. A2A is an agent to agent, like a library invented by Google, which allow you communication to each agents. So just like a agent architecture, so you cannot say I have only one agent. So when you implement microservice architecture, you have maybe 100 microservices or 10,000 microservices with a language agnostic way. Agent is exactly the same thing. So you have many multi-agents, and then that agents could be implemented multi-program languages, Python, Java, JavaScript from many other developer teams. So now problem is how to communicate each other. So that is a agent to agent, more language agnostic, and they give some great benefit for each developer team with their own schedule, and then test kind of thing. And here's I have a bunch of the agent here. So for example, like an analyst agent, and then when I go to an analyst agent, and then you can see the analyst agent, and then there are like a system message, like some kind of instruction, guidelines, scope, and for your AI model. So this is a multi-agent. So because I needed to analyze some like Argo and Kubernetes and deployment logs and metric and diagnosis as well, and a metric diagnosis, and then remediation. So there are many different roles and tasks for each agent. So if you give some like 10,000 different jobs for one single agent, that shouldn't be great architecture. So you can ask like a big giant model, like a Google Gemini, whatever you call that, but you can actually ask a random question. But in enterprise environment, it will cost a lot of money to use that. So that's why you probably sometimes use a small model and big model kind of stuff. So now I'm going to back to the rollout here. And then here is my UI. So my application status, you can see that all stable blue boxes like coming around. And then if I go to ID, and let me give it a try, probably memory leak. So in the Asian, actually, if you guys find like a null point exception, which means that it's not like a critical error, which means you can actually just roll back to your original thing rather than make a critical report. But if you find like a memory issue, and then one of my agent actually immediately create a pull request or issue to the original, the centralized repo, which means a real person SRE or platform engineer starting with investigating that issue because it's a huge issue in the production. So if I just go to memory, and if I add the memory and I commit it to that push the code and go to Argo, and my Argo rollout, I'm gonna try to refresh because the Argo rollout basically it takes a couple minutes to start. So I'm gonna just obviously start and then progressing. And then it's out of sync and progressing, and then it will start new progressing here. In the meantime, when I go back to terminal, okay, so now you can see that analysis run just starting 30 seconds ago, which is a trigger my agentic AI from like a AI metrics program. And then the logins keep changing. And then in the meantime, in the second terminal is actually my agentic AI application start communicate AI model and then try to analyze their logs, something like that. This is like a completion for my ChatGPT model. And you can see that here, diagnostic report. And then it's already do something, a lot of stuff. The autonomously is just to keep checking AI model until achieve the final goal. And then, and last thing is, successfully create the issue because this is a memory issue. And then the fallback is here, new issue. If I go to here, but number 6, and then I have the original repo, my application. And then if I reload the issue, and you can see that number 6, new issue automatically created by my Argo. But in the meantime, when I go back to here, you can see that the analysts run is a fail and the degrade, which means not going to deploy new application at all. So here just some kind of description, and then this is how to make your AI ops working all together. So let me go back to slide and then just quick summarize. We have like a 10 minutes left. So you just learn about like, the reason why you need to think about AI ops with the reasoning platform rather than like a traditional like a CI/CD, even progress delivery today. And then what architecture looks like and how that works, specifically with using Argo and Software and AI ops and like Java, among others, as a demo. And then let's say you start today. And then how do you do actually day one, day two operation, like a governance thing? And what about the tomorrow's job, like a future? So AI can fail all the time. So don't trust 100% your AI, even OpenClaw. You cannot share your bank account API key with the OpenClaw. So you can actually make some like a kill the power button on the AI. So if sometimes the AI might fail, and then you can actually roll back to original thing. And also you're gonna already set like a quota and a threshold. Sometimes the AI fail. It's you're gonna just intervene as a human being. It's a better SRE or a platform engineer. Of course, sometimes the AI model maybe don't care about your like sensitive information. That's why you need some guardrail, like a input guardrail, output guardrail. And then, so whenever you adopt and this standard new technology and platform layer, so you think about the budget and money. Maybe you can maybe report to your boss or the team leader. So some people, yeah, we need to pay for a new AI model, charge fee, but also we need to hire new people or new resources to develop new AI application, all about money. But just mention that with that thing, maybe you can, we can remove the many potential failure in production. Just compare which cost is more expensive between downtime in production or LLM token cost. And then in reality, many use cases you probably use only small model because I mentioned earlier, so you probably 10,000 agents at some point in the future, which means you probably don't need all giant AI model, only small model. And then also digital SI means like agentic AI, Python, Java, JavaScript, whatever you call that. So digital SI doesn't mean it will eliminate your job. It will help you out making better your job. So just imagine that you can work together with 3 different colleagues. And now every single person, SRE, platform engineer, they own digital agent, like SRE, working together. So I can work like the same time, like 5 hours, but by 5x or 10x productivity with the digital SRE. In the digital SRE, maybe deploy existing your each pipeline, each application alongside with. And then with all kind of stuff, you can maybe have like some ROI measurement and calculation. And then so maybe some get rid of some burden. You can, you're not going to really eliminate your job. So you make it better person with a skill kind of thing. Of course, you need to change your mindset and culture as well with that platform engineering. So you're not going to watch a big giant screen like this one and just walking and just looking at the red screen or red signal. Rather than you can actually manage, orchestrate like a rules, policy, agentic AI responsibility, and keep checking as like a new role, like a policy engineer, whatever you prefer to call. And then you can teach your agentic AI, not just rely on like a big giant model specialized with your business domain. That does not mean you can actually train a model like an AI engineer. Make you can actually like a design policy, like an analysis template, rather than fine tuning or other stuff. And then the other all kind of winnings, and then maybe you can convince your team colleague. Every time you're going to adapt a new technology, and then some of the people in your group may be very conservative. I don't like that, man. Don't even talk about me. But after you have some success, maybe you can maybe another conversation to convince them as well. So in 2026, this year, you cannot start by your own. there are many ecosystem from open source, like Homes GPT. I was like a KubeCon Amsterdam a couple of weeks ago, and then there was a keynote. They showed Homes GPT, advanced version of the Kubernetes GPT. It's to analyze all Kubernetes logs and then give us some great analyzing like a digital SRE and platform engineering stuff. But all like ArgoCD, of course, Argo rollout. But also there are some vendor and hyperscaler you can actually put together and stand up this AI ops platform. And with all kind of stuff, you can have more 10x faster detect or identify some error and failure and make a safer your production environment. And then you can define the policy rule for agentic AI, your own prepared language like English, Spanish, Chinese, Japanese, or whatever alien languages you prefer. So without all kind of stuff, you can keep secure your job. And then, so here's your call to action. So you can start today, but not gonna try to change everything as AI application or AI stuff. You can just pick one of your existing deployment today, like a one pipeline, one kind of policy, and then make a change that more like a rollout with the AI, agentic AI, making some digital SRE. And then with that, and you can verify this new technology and new architecture in some of the testing environment rather than production directly. I don't want you like ruin entire system. And then why do you do that? Oh, Daniel told me it's gonna work, but don't blame me. So this kind of thing. And then, so you probably stay today like a static rules, like a classical and traditional CI/CD pipeline. I'm not gonna say that's not good. So this is still great, but what is to make it better with the AI era? That is you're gonna changing your delivery platform as a living platform. Living platform, it means it let your platform making thinking over and over again, like a thing, act, and observe. So reasoning platform, that's like a DeepSeek R2 or whatever your AI model agent. So give us some more time and make it better and make it better result. And then this year, maybe a great start year, make it change your automation job, evolving into like a reasoning some stuff. That's it. That's what we all have today. Hopefully you guys enjoy this session and demo. And then you can reach out to us like a social media or some of the stuff. And we are more than happy to keep in touch with you guys. And then we have like 2 minutes left for questions. You can ask question in Japanese or English, whatever you prefer. Go ahead.
Very good talk. I just had a quick question. When you trigger the AI agent to collect the data to determine whether when it's making its analysis, how do you typically manage how much data to actually give it so it has enough context to make good decisions, but not give it too much so that it can degrade its performance or give bad information?
That's an excellent question. So basically, so the ArgoCD, the AI metric program, it actually sending all data when new deployment starting as a trigger. But in the agent side, you can actually specify your like a system message as a prompt engineering. So you can only gather some specific Kubernetes logs. For example, you're gonna exclude or you're gonna rule out some of the logs because that is like a trash logs. And then with the dead logs and dead logs agent is not going to send it to AI model to analyze. So that is some kind of filter or some of the stuff. That is and then like I mentioned, I showed that. So I actually 7 different agents. So which means that I'm not going to let one agent process the millions of different Kubernetes logs, including like a EDC or some of the logs. I just exclude the unnecessary logs, specifically the Argo rollout and deployment. So this define and specify in agentic AI side rather than like the other Argo side. Great question. Thank you. And okay, we are top of our hour and hope you enjoy the session, and hopefully enjoy the rest of the conference. And we will be stick around and just let us know if you have any other question. Thank you so much.